Okay, so we're gonna start some new stuff today. I want to take this. This book covers a lot of stuff. I want to take this section and spread it out over two days in class. We're going to talk about how we can do some stuff with functions to tweak them. So we can start with a simple parent function, and we can do some stuff to that, like translate it, slide it horizontally or vertically. We can reflect it over the x-axis or the y-axis. We can stretch it vertically or compress it vertically, stretch it horizontally or compress it horizontally. And we can take the simple parent function and turn it into a more complicated version of the function, right? That's kind of our goal. For example, if we were to, let's just take a really simple example like a line. Okay, let's say that we want to start with a really simple function, f of x equals x. Okay, simple line. How would I graph that line? What's the y-intercept? I heard it. 0. Slope? 1. Okay, so then we'd start at 0 and we'd go up 1 and over 1 to get another point, connect, and extend. So we'll call this our parent function. So that's our simple starting place. Let's say we want to do some stuff to that, though. Let's say that we want to, let's say we want to do something like, maybe we want to stretch it out vertically by a factor of 2. Okay, so one thing I want to do is I want to take all of these points and I want to move them up so they're twice as far away from the x-axis as they used to be. So this point right here, then instead of being up 2, I'd have to go up to 4, right, etc. Okay? So there's one thing I want to do. Okay, we're going to find out that we could accomplish that by just multiplying the whole function by 2. Okay, that's one of our parameters. It ends up being this parameter that we're going to call a. What's a parameter? Parameter is just a special number. It's a number that's going to tweak the function in ways that we can control. So this is going to be the vertical stretch parameter. So what do we do there? The red function we could call g of x, and that's just f of x multiplied by 2. Okay, in fact, I'll write it that way. We won't even write it in terms of x. We'll just write it in terms of our original function, f of x. Okay, so that's one thing I wanted to do. Let's say we also wanted to take this line and we wanted to slide it up. Let's say we want to flip it around. So the slope is going down instead of up. We can do that. To do that, all I've got to do is multiply by -1. If a is negative, we're going to find this, we're not going to talk about this today. We'll talk about this later on. But if I make that negative, what that accomplishes is it takes our function and it reflects it over the x-axis, right? So now, if g of x were -2 times f of x, what did that negative sign do? Did this. That point, instead of being up 2, would be down 2, right? Instead of being up 4, this point is down 4. So, well, you get the idea. So the green function is what we get when we multiply the red function by a minus sign, by -1. Okay? What if we wanted to take that green function, the last thing we want to do is let's slide it up by 3. Okay? So we want it to be, all these points are going to move up by 3. So it's now going to look like that. Take the whole thing and slide it up by 3. How do we accomplish that? One of those, there's only 4 parameters up here. Which one of those do you think controls the vertical motion? We'll talk about it. It's no big deal. It's the last one. Yeah. So the last thing I could do then, if I want to get that purple line, is take my green function, which was -2 f of x, and I'm just going to add 3 to it to slide it up. So you get the idea? what we're seeing then is that each of these parameters up here, I can control those by putting in a specific kind of number. And I can tweak the function in a way that we'll understand. Now, we're not going to do all of that stuff today. We're going to start with just simple stuff. We're going to start with how do we translate or slide the function horizontally and vertically. And then we'll probably maybe just start to look at how we can stretch it or shrink it vertically. Okay? So let's have a look here. All right, so, and I'm just looking at the interactive lesson for section 1.3. So you can go see this very same thing. This is the student version of it right here. So the first parameter we're going to look at is k. Okay, what happens if we pick a value for k? All right, so we'll forget all the other ones. We're just going to take our function and add k to it. Well, let's say that this blue graph right here represents our parent function, f of x. Okay, so before we go any further, what's the value of f of x when x equals 3? Now what's that mean when I say the value of the function when x equals 3? What am I asking about? The y value, right? Because f of x is just a fancy name for y. Think what f of x does. We input x values and it spits out y values, right? So what is the value of f of x when x equals 3? It's 3, isn't it? Right? Okay, so what's the value of f of x when x equals 5? It's 5. So if we're going to create some new function, g of x, that's based on f of x, but what we're going to do this time is we're just going to add 3 to all the function values for f of x, what's that going to give us? So if I input 3, and f of x has a value of 3, what's g of x going to have for a value? 6. It's going to be 3 plus 3, right? So it's going to be 6. If I input an x value of 5, the output value for f of x is 5. What's g going to have? 8. I'm going to have to add 3 to that, right? Okay. If I input 7, what am I going to get back? 6, right? Because it's going to have start off with an f of x y value of 3, and I got to add 3 to that for g, right? So that should be 6. And then if I input a y value or an x value of 9, what should I get back? 8. Okay, good. So what'd that do? Moved it up. So there you go. So we know then that k is the parameter that controls vertical slides or translations, right? So when k was positive, we translated it in the positive y direction, which is up. What's the negative y direction? Down. Good. So how could I accomplish, let's say I wanted to move this thing down by 2. What would I do? Okay, I would add -2, wouldn't I? Because k would have to have a negative value to be a downward slide. Does that make sense? So adding -2 is the same thing as subtracting 2, right? So then we could just write it this way. G of x equals f of x minus 2. Same thing as plus -2, right? And what's that going to do? Well, isn't that just going to slide it down by 2, all of the y values? Say it again.
So like, for not even doing math, or you just take, like it said -2, so why don't you just go down to?
Well, you can. You can. But think of it this way. If I've got a function like, I think I understand your question, Ben. What if I've got a function like this, though? What if I've got a function, let's say my parent function is f of x equals x squared, okay? So that's going to go through, it's going to be a parabola, right?
Yeah.
There are an infinite number of points on that function. And so we want to come up with a way where we don't have to take each of those infinite discrete points and move them. We want to come up with a way that we can just create a new equation, a new function, that when I graph it, like on my calculator, for example, is going to take this and maybe move it down by 2. So all I'd have to do then is say, okay, well, g of x is my original function plus -2. See what I'm saying? And that's going to create the function that does that. Okay?
Can
sense?
It's pretty much faster than taking each and every point. and changing it.
Right, and so now we don't have to go through that whole process anymore, right? We just know that if we want to slide a function vertically, I control that by controlling the value of k. I can do whatever I want to in terms of a vertical slide by just picking a value of k. Positive for an upward slide, negative for a downward slide, right? Okay, so let's look at then, we got that one. Let's look at something a little different here, whoops. Okay, let's look at something like this. Let's pick a different parameter this time. K was the parameter that's added to the very end of the function, right? Positive value goes up, negative value goes down. H is a little bit different. H is the parameter that's subtracted from x inside the function, right? So what's that going to do? Let's take an example of, let's say that h equals positive 5. If h equals positive 5, then doesn't that, and I'll make this a little bit bigger here so you can see this a little better. So we're going to define g of x as f of x minus 5. So that's my value of h, right? Okay. What's that going to do? Well, let's look at our original function again for a second. If I go up to my original function here, and we're going to do this to it. We're going to do this to it. What happens if I input an x value of 8 into g? So g of 8 equals f of what? 8 minus 5, which is what? 3. Everybody see that? So inputting x equals 8 into g is the same thing as putting in 8 minus 5 or 3 into f. Agreed? Okay. Well, what is f of 3 equal to? So f of 3, that just means the y value of f when I plug in an x value of 3, right? Okay, so what am I going to get for that? I'm going to get 3, aren't I? Right? F of 3 equals 3, so g of 8, if I graph g, must equal 3, right? I got to go down a little bit on this one because it's not a white graph. Let's go down to here. How about instead? So g of 8 equals, oops, equals 3. Okay. What is g of 10? That's equal to f of what? 5, right? Did you ever see that? Because I'm subtracting 5 from x. Well, what is f of 5? F is the blue function. An input of 5 gives me an output of what? 5. So you get it then? G of 10 would equal 5, right? So those points go together, right? Maybe I'll go ahead and just connect those. Okay. What about, what's g of 12? That's the same as f of what? F of what? 7. What is f of 7? 3. On the blue function, if I input 7, I get an output value of 3. Okay, so g of 12, if I put in 12, I get back 3. And then finally, what about this point? G of 14 equals f of what? 9, because I'm subtracting 5, right? And that is 5, right? So what did I do? How did I get from blue to red? What did I do? What did I do to this function to get this one? That graph to get that one? I just slid it to the right. By how much? By 5. Okay, so what's that tell us? That tells us that this parameter h right here what does h control? If I plug in positive 5, it slides in the positive x direction to the right by 5. Agreed? So h is the horizontal shift. What if I wanted to shift this thing to the left by 2? What would I do? I'd plug in h equals -2, right? Does that make sense?
Already.
But that's, so look at I know what you're saying, and you're right. So we're going to get g of x equals f of x minus -2. But what is x minus -2? You subtract a negative, that's the same thing as added. Good. Okay, so then that looks like f of x plus 2, right? Does that make sense? Okay, so let's try something here then. I want you to tell me what to do here. Okay, we're going to start off with this is our parent function. Oh, whoops. I happen to choose a square root function, but it doesn't matter. So there's f of x equals the square root of x. Doesn't matter what the function is, though. I want you to tell me, how could I slide this thing to the right by 2? What would I have to do to the function? So if I go up here, there's what I graphed. Y equals the square root of x. If I want to slide this to the right, I'm going to create a red graph that slides the blue graph to the right. What do I have to do to my square root of x function? I got to subtract 2 from the whole thing? Okay, so I got to subtract, that's my h value. I have to subtract 2 from x, right? So I'll go ahead and put these in parentheses. I don't really have to because they're implied parentheses inside the square root, but it makes it look better maybe. So x minus, and the h value I'm plugging in is positive 2, right? H is the number being subtracted from x. So what's that do? There's my blue graph, there's my red graph. It slides it to the right by 2. Agreed? If I want to slide it left by 2 instead, let's go down, we'll go to the next graph and take the square root and slide it to the left by 2. What am I going to do? Square root of, whoops. Square root of, Riley, what am I going to do? I want to slide it to the left by 2. Plus 2. X minus -2, which is the same as plus 2. And sure enough, it's left by 2. Okay, now this is tricky. How about this one? Let's say we want to slide it to the right by 3, and we want to slide it down by 1. What's that going to look like? Right, so that involves both horizontal and vertical shifts. Horizontal shift is controlled by the parameter h, vertical shift is controlled by k, right? So if g of x equals f of x minus h plus k, we said we wanted, what I said I wanted to do, I wanted to go right by 2, and I want to go down by 1.
That's so not what you
Is that what I
said.
said?
To the right by 3 and out by 1.
Oh, okay, well, whoops. Well, that's what I'm saying now. So what's that gonna tell me? What does this tell me? Right by 2 tells me what? Okay, so it tells me h equals, well, h equals 2, so I'm gonna have x minus 2, right? Because h is the number being subtracted from x, right? So we get h equals 2, and then this one is telling me what? K equals -1, right? And so if our function is a square root graph, let's say we started off with our parent function is f of x equals the square root of x, then what's our graph gonna look like? So I'm gonna get the square root of, the square root of x minus 2, right? And that's going to do this part. Outside of the function then, at the very end, what do? Subtract 1. Okay, let's try it. Okay, so we said square root x minus 2. I got to scoot to the right, get out of the square root, and then minus 1. There we go. Right 2 down 1. Make sense? Okay. But what about, let's move on and try something different. So what do we know how to do now? We know how to independently shift a graph horizontally by a predicted amount and vertically by a predicted amount. Okay, there's more stuff though. What about the parameter a? Okay, a is the number that's being multiplied by the function out front. Okay, let's let a equal 2 and see what happens. Here's my function f of x, right? So if g of x equals 2 times f of x, what do I get if I input a value of, say, 3? Well, what is f of 3? And we've already done this a bunch of times. This is f, so it's 3, right? But g of x has to be 2 times f of x. So g of 3 equals 2 times f of 3 equals 2 times 3 is 6, right? Okay, so that's going to be right there. Okay, I won't go through this whole process here, but you tell me then, what is g of 5 going to equal? What's f of 5? 5, but I'm multiplying f of 5 by 2. So it's going to be 10, right? Okay, so, and we're going to get the same kind of stuff here, aren't we? Because f of 7 is 3, g of 7 has to be 2 times that. so it's 6. And f of 9 is 5, so g of 9 is going to be 2 times that. Well, what did we do that time? Yeah, we stretched it, didn't we? We stretched it vertically. Now, do you see how a stretch is different than a translation? If I translated this, you might look at this and say, oh, okay, well, we just slid it up by 3. It's not, is it? This point got moved up by 3, but this one got moved up by 5, not by 3. What we really did is we took the distance from the x-axis and we stretched it out so it was 2 times more than that. So when we say we stretched by a factor of 2, we mean we're multiplying the y values by 2. That make sense? Okay? How do you think we could compress it instead of stretch it? Okay, divide. So like, what would happen if I divided by 2? Cut it in half. Okay, let's think of it though. Isn't dividing by 2 the same thing as multiplying by 1/2? Okay, so let's think of it that way instead. Because if we look at this, a is the number that's being multiplied by f of x. A isn't, we're not dividing f of x by a, we're multiplying f of x by a. So if I want to compress it then, sure, it's the same thing as dividing by 2, but really what we're doing is multiplying by 1/2. Okay? What do you think the cutoff is? What kinds of values of a are going to stretch the function? Values that are what? Greater than 1. Agreed? If I multiply a number by a number that's bigger than 1, is it going to get bigger? What kinds of values of a are going to make the function compressed? Less than 1. Greater than 0, right? So they're positive, but less than 1. Agreed? If I were to multiply this by, let's just see what would happen. If I were to multiply this by 1/2, for example, what am I going to get? Well, if the output of f of x is 3, the output of g of x is 1/2 of that. So it goes right there. If the output of f of x is 5, then g of x is 1/2 of that, so it's 2.5. So it goes right there. And then same pattern, right? So look what happens. We took the blue function and we just squashed it down towards the x-axis. So every point is 1/2 as far away as it used to be from the x-axis, right? Okay, good. Last issue. How much time we got? Okay, we got a little time, don't we? Oh, yeah, we got enough. Perfect. Perfect. So one last thing I want to look at. What about this? The last parameter is the one that looks the weirdest. Right? We took care of h and k and a, and there's only one more left. If we go back and look at this, where we started, right there, right? We took care of A and H and K, but the one remaining is B. That's weird. So B is in the denominator of the fraction 1/b, and that's the fraction that's being multiplied by x minus h. What does that do? Well, let's just take the function, let's just take g of x equals f of 1/b times x. Let's let b equal 2 this time. Okay, so b equals 2, and let's see what that does. Okay, so what if we input a value of 6 for g in our old function, right? And we kind of need to maybe see that. Okay, let's do it. We'll do it right up here. Right there. Well, we'll just look on it. Never mind. So we remember what those values were, right? We can kind of remember what that function looked like. I wish we could stare at a graph while we were doing this. But if I input a value of 6 for g, that means I'm inputting 1/2 of 6 for f, right? What was f of 3 equal to, you remember?
3.
It was 3, wasn't it, right? So if f of 3, which is 1/2 times 6 is 3, then g of 6 must equal 3. Okay, you can already maybe predict what's going to happen. Let me write that down. So g of 6 equals f of 1/2 times 6 is f of 3, which is 3, right? Okay. What value would I have to input for g to have that be the same thing as inputting 5 for f? What do you think? G of x is defined as f of 1/2 of x. So if I want the number that f is being fed to be a 5, what number am I multiplying 1/2 by to get that? 10, right? See that? So inputting a 10 for g is the same thing as inputting 5 for f. And if the output of 5 for f is 5, then that's the output for g, right? If I input 14 for g, what's that equivalent to as an input for f? I multiply by 1/2, 7. When I input 7 for f, I got back 3 for y, right? So that's my output for g. Okay, which number would I have to input for g if I want to have 9 being the number input to f? 18. My output for 9 was 5. So I get 5 for g. What's that look like? Looks like that, doesn't it? Look what happened. I had to input numbers that were twice as big for g to get the corresponding outputs because I was multiplying them by 1/2. So what's the effect of that then? What did we do to the blue function? We stretched it in which direction? Yeah, we stretched it horizontally, didn't we? We stretched it away from the y-axis, right? Does that make sense? Okay, so there is a very short assignment. I think it's 8 problems. It's due day after tomorrow. That just covers this stuff. Shouldn't be a big deal. Have at it. Tomorrow's a work day.